Hello everyone, today I'd like to tell you about our research on isotope composition of ancient cherts from a combined perspective of triple oxygen isotope measurements in bulk and in situ isotope investigations. Scientists had been interested in oxygen isotope composition of ancient sedimentary rocks so that they could reconstruct the temperature of the oceans in the deep past all the way back to the Archean. One possible interpretation of this trend is a much higher temperature of the Archean oceans, up to 70 degrees Celsius. Alternatively, the delta TNO of the seawater must have been a lot lower itself. Both interpretations are deemed somewhat unrealistic, questioning the quality of isotope preservation by these proxies, and for decades now, this systematic trend does not have a universal explanation. To get a new perspective on this, we introduce a dataset based on triple oxygen isotope values of cherts. The advantage of this approach is in having two isotope values and thus two equations readily solved. Theoretically, this permits reconstructing parental fluid values and temperature precipitation at the same time. Additionally, using some global contribution figures, we estimated by how much and which way could seawater evolve on the geological timescales. In our model, the answer is by not much, about 4 per mil total and delta TNO ratio. Thus, we are mostly focusing on the processes that affect silica precipitation and diagenesis. Further, we conducted in situ isotope measurements using the secondary ion probe CAMICA 1280HR hosted at the Swiss SIMS facility at the University of Lausanne. The same exact samples were used for the triple oxygen isotope measurements in bulk. Importantly, we find up to 10 per mil differences in delta TNO between different generations of quartz. Using trace elemental concentrations, silicon isotopes, and Raman spectroscopy of organic matter, we guided our interpretations in addressing the influence of diagenetic alteration. Here I show a compilation of previously published chert values, including our new dataset. The takeaway message here is that many cherts of different ages are shifted to various degrees below the value of equilibrium fractionation with modern-day seawater at any temperature. Generally, these values do not require a drastically different isotope composition of seawater. Instead, we suggest that many cherts represent a mixed input of marine and diagenetic fluids that are shifted from the seawater value due to the reaction with rocks. We further suggest that the Archean cherts shown here in red reflect a mixed contribution from marine and hydrothermal silica. If you have questions on this topic, please send me an email, talk to me on Discord, and see our publication that comes out in Reviews in Mineralogy and Geochemistry early next year. Thank you.